like to welcome our next presenter, Ammar Latif, who's going to be talking about an IP studio production case study and talking about some good and some ugly things. So that's always very useful information for the audience. So take it away, Ammar.
All right, guys, good afternoon. So my name is Ammar Latif. I'm principal engineer at Cisco. And this talk is about an actual customer implementation, one of our first back in 2016 timeframe. So sharing with you what we learned from it and some of the lessons learned. So the facility that we are building for this uncompressed video was a new building, and it was a full studio. They had 5 studio rooms, 2 control rooms associated with it, and it was a TV station. And the driver for the installation was it's a new building, so it's a new build-up, and they decided to go with IP for it. And the decision at the time, they typically tell us that, you put initially the SDI router. That's when you start building the plant. You put the SDI router, then you start layering. So here, similar thing happened, is that they decided on an IP fabric, and they started layering on top of it. At the time, there was no ISO 4, ISO 5. So you will see that affected some of the signaling. In the consideration was broadcast controller. So which broadcast controllers should I select? Which gateways should I select? And what media controller should I select as part of the project planning? So let's go into a bit of details. So for example, as they were selecting the fabric, as the customer was selecting the fabric, how do I tie things together? One consideration was they decided to go with spine leaf. They decided to go with spine leaf architecture. And spine leaf architecture, just so that they can cover the facility, they have flexibility to put leaves closer to the endpoints. It also allowed them to use some cheaper active optical cables to connect directly to the endpoints. So for these considerations, they decided to go with spine leaf. So one consideration was to go with a single spine, multiple leaves. They started with that, and the consideration there is basically the number of spines and number of leaves is driven by the I/O. We counted here that we wanted to do 10,000 by 10,000 router. Like roughly, if I remember correctly, the target was 10,000 by 10,000 matrix to reflect it into spine leaf. So one option was to connect the senders and receivers to the leaves and then have a single spine. Now, what they noticed, the customer noticed, is having multiple spines gives them the ability to scale out and add more leaves as they needed. So what happened is that they decided to go with multiple spines so that they can scale out the I/O. And as they need more I/O, they just plug it into both spines. The consideration here is, of course, bandwidth coming in and out from the, for this fabric is basically symmetrical. So whatever bandwidth you have or I/O going into the fabric, into the leaves, needs to be matched to the spine. And if you notice here, the senders and receivers in this case were not connected to the spines. They were all connected to the leaves directly. So very similar to our previous colleague from BBC. Very similar architecture, where spine leaves and then connected. Now, the signaling behind it, if you noticed here, the signaling behind the senders and receivers, what we went with is IGMP. So signaling is IGMP with a broadcast controller. In this case, it was a GV convergent, and a media controller, which is Cisco's DCNM. Now, from a high availability perspective, the way the fabric was built was redundant side A, side B. Red and blue if you want. And they were, so remember we discussed two spines, baby spines, multiple leaves, and then we built basically side A equivalent side X, side Y for redundancy. And then each of the endpoints, whether it's senders or receivers, are basically doing -7, connecting to both sides of the fabric. If you notice here, these are airtight, air-gapped. No connectivity between this side and this side. So now the question is, how do you manage the signaling within this fabric? And for this project, the idea was, or what they used, is non-blocking multicast. Non-blocking multicast. And what is non-blocking multicast? Is basically the ability to ensure no oversubscription in these links between the spines and the leaves, or even towards the endpoints. And it's very similar to, I think, what my colleague, the previous colleague was discussing. Is basically use existing standard-based multicast signaling, and then what we did at Cisco is changed make it bandwidth aware. So the idea is we made the protocol bandwidth aware. So again, this is all standard-based IGMP signaling with PIM multicast signaling, but we made it bandwidth aware by adding a shim to the protocol to be able to signal, is this an HD stream? Is it an audio stream? Is it a metadata, etc. So basically, the fabric that you saw is running NBM, here, non-blocking multicast, in the fabric, distributed architecture, running traditional routing, with this, again, with this shim of being bandwidth aware, and then the endpoints connect to the fabric and requests streams, and then the fabric deciding, do I have enough bandwidth or not to allow it in. This way, this is how we manage the deterministic nature of the fabric. So one of the requirements that came later is that I have a remote facility. Was 10 kilometers away. And they needed to basically do some remote production. Using, again, 2022, so uncompressed video. So what we did is basically extended over, they leased fiber, and they extended the leaves that we had, they extended them to the remote facility. And that became just another leaf managed fully by that process, the non-blocking multicast process. So again, the remote production concept was introduced by extending leaves out to the remote facility, and it became just another real leaf that is managed, and then signals were going back and forth, and again, bandwidth managed by the non-blocking multicast process. So with that, what the customer noticed is that truly the main issue they had day in and day out, once they went into production, and this has been in production for about a year, the main issue is day 2 operations. Once you set up the network, that's it. It is set up, it functions, IGMP, multicast, it works. How do you troubleshoot? How do you troubleshoot endpoints? How do you troubleshoot like day 2 operations for broadcast engineers? And how do you let broadcast engineers who are not CLI and switch savvy be able to troubleshoot this? So this is really what the main focus of a lot of the activities that we saw at this customer site. So first of all, they started to rely, so we need to be all as an industry more comfortable with streaming telemetry. So basically, we stream, and the fabrics, we stream telemetry of states, of the network states out, and using out-of-band management connectivity, and then put it into a media controller. In this case, they were using Cisco's media controller, but you could have your own, for example, streaming telemetry receiver making sense out of it. what I'm showing here is basically the Cisco DCNM media controller for basically showing the flows, where the flows are, where the hosts are connected, and if you are you're trying to troubleshoot what issue, it is a tool to give broadcast engineers access to the state of the network. I like this picture just because it looks cool. This is basically a reflection of all the spines and leaves. So all these are leaves, and all these are spines, 2 spines, and you can count how many leaves. One of them is a remote leaf. And then basically all the other gray areas, the grays, is basically hosts. So these are basically the IPGs that are connected, the multi-viewers, they are all showing up here. And basically, this is just an initial view for a broadcast engineer to look at what they need to troubleshoot, and they can zoom in. For example, if they are having an issue with a particular IPG or a particular multi-viewer or a particular leaf, you can click on it. So you can see, for example, some of these are orange. Some of the links are orange. And orange means, they were reaching saturation, like 70% utilization, for example. So you could quickly have a quick overview. Now, this is all driven by streaming telemetry from the switches. At the end of the day, this is just an industry standard. Again, all about day two operations. Multicast, so SDI, as you know, SDI is the new multicast. That multicast stream is the new SDI for us. That's basically it. It is multicast. So how do we troubleshoot multicast? If you ask any IT engineer, forget broadcast engineer, if you ask any IT engineer to troubleshoot multicast, it's a bit of a pain because it is reverse engineering. You're basically you need to start from the receiver going back to the source. Very painful. 3 troubleshooting. So again, back to the streaming telemetry, what the customer used is the ability to stream telemetry out to this media controller where you can see visibly, you can see where the source is, where the destination is, and how is it going through the fabric. So again, think of day 2 operations and how you handle that is basically give them the ability to troubleshoot and locate quickly multicast streams. Flow statistics is another thing that they are useful to. Now, another thing we noticed in this environment is that you need to be able to quickly grab any flow as it is leaving the port. So if you are troubleshooting something, you need to see exactly what is coming in or leaving that port, exact replica. So of course, in a IT environment, we know how to set that up. Span, you set up a span. The problem is, we have, like, I'm calling out, for example, here, Tektronix. You have Wireshark. You have some troubleshooting devices that you can plug in. The problem is you have a single port, 2 ports, 3 ports out of it. So what we did is we created a concept called Diagnostic LAN. So you know how we have Media LAN? What we did is, at the customer side, what we did is Diagnostic LAN. So this Diagnostic LAN could be a single switch where each and every leaf and spine is connected to, and then you can manually tell the system to forward the traffic from any of these ports to Tektronix, for example, or to a Wireshark. And basically, you start troubleshooting quickly. Why? Because you will see many of the troubleshooting is you're trying to figure out this endpoint, what is it sending? Most likely, it is sending the wrong TTL. Most likely, it's sending the wrong IP address. This is the type of issues we need to troubleshoot day in and day out. It's like that, TTL, IP address wrong. Sometimes they start sending, so we had one incident where one equipment manufacturer was plugged into the network and it started flooding the network. Now, we protect the fabric, but it is very painful to identify that one endpoint. So you need this troubleshooting tool to quickly pick the traffic from the port, send it out to a Wireshark, or send it out to a monitoring device, and then identify quickly. So I think if you see here, all about day 2 operations. So this Diagnostic LAN is something worth considering as you are building the facility. Timing. So my previous colleague talked about timing and PTP. We learned quite a bit as an industry, as Cisco, and as this customer, PTP. So what is the deployment we have in this facility? We have 2 grandmasters connecting to PTP leaves. We use PTP leaves for distribution. And then these PTP leaves feed into the spine leaf network on both sides. So if you see, this is side X, this is side Y, and then this is the architecture. So if you noticed here, what we broke is the airtight. If you noticed, we connected now, through this PTP leaf, we connected X and Y. Right? So why is that? Why did we connect them together? We said they are airtight. Because currently, the standard, if you have an endpoint that's connected to both X and Y, that endpoint does not like to see, usually, what we've seen, doesn't like to see different grandmaster IDs. So they expect to have the same grandmaster ID. So what we did now, hopefully it will change in the standard, but for now, what happened is that we had to basically do the same grandmaster to both fabrics and have them do the election themselves. So in fact, we are in production with this architecture. We had actually 2 incidents where the grandmaster failed. One of them was GPS signal. One was, an error in the grandmaster. The failure is seamless to the endpoints. The error was seamless to the endpoint because the election kicked in, boundary clock is running, election kicked in, and that resolved the issue. So basically what I'm saying here is this is again very similar to the deployment that my previous colleague was showing us. Very similar PTP deployment. PTP leaves feeding both spines, and just a consideration from a PTP perspective. But PTP, one thing to set it up, you need to monitor it. You need to monitor it. So I think I have a slide on that because I want to talk about, I think I have a slide on. Okay, so 2 considerations. One is, there is a misconception in the industry. When you're running boundary clock, they always default to 2059 in the grandmaster. The grandmaster, you can set it up to 2059, 1588, or AES67. There is a misconception. My endpoint require 2059, thus I need the grandmaster to be 2059. That's wrong. It's not needed. You could set it up that way, but not needed. What is needed is basically the grandmaster, when it sends the signal to the spine, that's it. If you set up grandmaster to 2059, at the spine, that signal is terminated, then it's up to spine to deliver whatever signal it needs. That's how it works. So what I'm saying is, it doesn't need to be your grandmaster setting up 2059. You could set up your grandmaster to 1588 or even AES67. It doesn't need to be 2059. The key is, because you're running boundary clock, the spine is a boundary clock, the leaves are boundary clock. Now, the leaves will deliver per port either AES67, 1588, or 2059 per port, depending on the endpoint requirement. So this is, again, just a misconception in the industry that affects us when we deploy. Because when you deploy 2059, there is a tax of these management packets. That's a problem. So again, just keep that in mind as we are progressing. But look at this. This is, again, day 2. Remember day 2. The network itself, no issue. It is day 2, troubleshooting and operations. PTP, we had initially to build a script for the customer to go into each switch and generate error logs when the corrections of PTP go beyond a certain point. Typically 1 microsecond, 1,000 nanosecond. If your corrections goes above 1 microsecond, you want to be alerted. There was no tools at the time to do that at scale. So we wrote script to basically monitor correction ranges, changes in grandmaster, so that you make sure when there is a change in the grandmaster, you are alerted, and maybe rogue GMs, a grandmaster that is rogue, that is connected. So what we did is initially we did a switch level monitoring. We are scripting and we alert on PTP. And now what we are doing is basically, again, stream stream the information to a media controller and have the media controller act on it. So again, PTP is monitoring is another one. So for the benefit of time, the other thing is training for the broadcast engineers. These fabrics are simple, but still the broadcast engineers need some training. So SIMT has training, has CCNA training. Cisco also, I left a link. We have two types of training: IP Foundation for broadcast engineers and operating an IP fabric for media. So just an FYI for your broadcast engineers, it's a good stepping stone in learning the technology they need to operate these fabrics, because again, training is a big issue. So we'll wrap up by, can I sleep at night? My operation is running, can I sleep at night? And the answer is really depends. How deep is your sleep? How deep you want it to sleep? Fabric setup is you set it and you leave it running. So IP fabric for media, you set it up, you run. The issue is day 2 operations and troubleshooting. Day 2 operations and troubleshooting. One thing we tell our customers, do an onboarding process. Every time you plug a new equipment, try to set up, at least if it's a new vendor, try to do an onboarding process. Put it in an isolation within the network. Like do an onboarding, a good onboarding process. You plug it in, you make sure it sends good packets, then you move it into production. IP training, we discussed about the IP training needs. PTP troubleshooting and visibility. So now I haven't seen that yet. This facility went live without ISO 4, ISO 5. So they relied on, in this case, GV convergent and integration to the endpoints. What that made easy for us is that made, you could have, because it's all IGMP, you could have disaggregation, meaning you could have multiple broadcast controls running at the same time, because all of them are signaling using same IGMP. That was one benefit the customer mentioned to us. And then 2022-6 versus 2110, no big difference from a network perspective. No difference. From a network perspective, these are all multicast streams. Same PTP is running. The only difference is the scale of multicast. So as long as you are comfortable with the scale of the multicast, then we are good. So for the benefit of time, I will wrap up. This facility was planned 2016, went into production. So the building was you know, I think it was built up around they delivered it around 2000, I think January 2018. We went live 2018 October, and we have been up since then with 4 newscasts every day. And so far, I am still employed. So we are good. That's the good news. I think that's it for me. Thanks, everyone.
Okay, Ammar, thank you very much. Now, question for you. First of all, are there any questions from the audience? One question for you. So let's say you were going to start a project like this tomorrow, okay? What would you do different based on the technology that's available today versus the technology that was available when you were doing this original installation?
That's a good question. So what I would do is set up a lab. So set up a lab quickly, so that you can test interoperability of endpoints. That's number one. From a fabric perspective, no change. The only change you will see is the speeds, port speeds. Like now we are heading towards 400 gig. That's basically the difference. Is we are heading towards 400 gig. That was not available even back then. That's number two. And then wait for the full interoperability as far as ISO 4, ISO 5. The ISO 4, ISO 5 promised land is very good. It helps us bring up these facilities faster. We just need to make sure that the industry is onboarding that protocol quickly.
Okay.
Thank you, Wes.
Any other questions?
Yes, so the slides will be available. The training URL is easy. www.cisco.com/media. Go Media.
Okay, and the video here and the presentations will be posted at vsf.tv, as well as a link will be sent to everybody who has their badge scanned at the front desk here. So, and you're bringing that up right now?
I'm sorry, I did not mean to do that, but but that's what happened.
Hey,
So
just
basically,
give us your login. We're good from now. Yeah.
that's right. So it's www.cisco.com. Go Media is the link. Yep, that's the link.
Okay. Thank you very much.
Thank you.